Alright, so this video is about energy. We'll do a really quick physics definition of what is energy, and this isn't going to make a whole lot of sense to you right now because we haven't talked about work, and we won't talk about work for a while. But according to physics, energy is the ability to do work. Alright, so more energy means more ability to do work. Well, again, we'll talk about what work is later, but just know that that's the official definition of energy. You guys know really functionally what energy is anyway, so we can just go with basically your working understanding of what energy is right now. So we're just going to talk about several different kinds of energy in this video, and we'll kind of run through them pretty fast. So here we have a picture of a certain type of energy, which is contained within that device right there. That's a water ball cannon, or a water balloon cannon. Alright, and you've got the guy over here who's pulling it back. You've got all the energy stored in these straps. I wonder if you can guess what kind it is. Among these, we have gravitational energy, chemical energy, nuclear, electrical, strain, light, heat, sound, and mechanical. In a sense, this is mechanical energy because it involves motion, but the more accurate one would be strain. Elastic strain energy is what's being shown here. Cool. Let's see an example of another kind of energy. Wonder what this one is. I hope you're following along here and getting a little bit of a kick out of it. There's probably a couple different answers you could give for this one. We're looking at these guys here. They're on top of that girder there, who knows how far above the ground. Probably this is a comedy act, so I'm guessing this isn't a real image, but if it were a real image, they'd be pretty far off the ground. They have a lot of gravitational energy. Possibly there's some sound energy as they're screaming hysterically of fear, but you know, anyway, main thing here, gravitational potential energy. What do we have here? Yeah, you guessed it. This is screaming. This is a scary baby face. Screaming. This is a cat, very angry. So, what is that? That's sound energy. Nice. Alright, here's another one. Not sure if you're familiar with these symbols or not. This one is probably one you've seen before. And then that's sort of an iconic image of this kind of power plant. This is nuclear energy. Alright, now in the power plant here, there is quite a lot of other things going on. There's a lot of heat, there's a lot of light, there's a lot of sound, mechanical, electrical going on in there. But the main one I was getting at with this picture is nuclear energy. Alright, and then here, last one I think that we've got here on our slides. We've got a coal-fired power plant. When you burn coal, you release its energy, and it is chemical energy that's stored in the coal. Now, of course, there's also heat, there's light, there's sound, there's electrical going on there. If you look at this conveyor belt, the coal is being dropped down into the plant, so you could call that gravitational potential energy, actually. There's mechanical, basically all kinds of energy that you can imagine, except nuclear. No nuclear. But otherwise, everything else is here. So, nice! Alright, so just to define really quick a few things. Energy, as we said at the beginning, is a measure of the system's ability to do work. So the ability of a system to do work, that is the technical definition of energy. Right. Most forms of energy, so of all those forms we just looked at examples of those could either be kinetic or they could be potential, most of them. Alright, and we'll get into that more as we go along. Energy can come in many different forms, as we just saw. Alright, it can be converted from one form into another, so energy can be changed within a system, and it can be transferred from one place to another. Alright, so that's basically what can happen with energy. All right, so we want to look at some examples of energy conversion. So we got here energy conversion, and then we've got a picture right there. And the question is, what form is the energy being converted from, and what form is it being converted into? So what is it being converted from in this case? We have a guy with an electric drill. What energy are we starting with in the electric drill? I kind of gave it away. It's being converted from electrical. What's it being converted into? Well, you have several options there. I'm not going to write this all out because my handwriting is awful when I'm using my finger to write on this screen. So it's being converted from electrical energy, and your answers could vary. It's being converted into, there will be sound, quite a lot of sound. There will be heat from the friction with the device there. There's definitely motion with the spinning of the drill bit. So those at least are really good answers. All right, here we have another example. If you can't tell what that is, this is a match head really zoomed in close, and it's striking the surface there, so this is like heat coming off. So what do you have there that you're starting with? You're starting with chemical energy in the match head and in the wood of the match. And then what's it turning into? Well, heat and light. Heat and light, mostly. A little bit of sound when you strike it. Alright, here's another example of energy conversion. This guy is Lance Armstrong. He was a very famous cyclist who won many Tour de France tournaments, and later it was discovered that he was apparently doping with drugs, and they took away all of his victories. All of them. Fun times. Anyway, I put this together when he was still famous and not infamous for cheating, basically. So, energy here. What energy is going on there? Let's look at the guy riding the bike. Energy is being converted in several ways there. Mainly, it's the chemical energy in his body is being converted into mechanical and heat energy mostly as he pedals the bike and his muscles get warm. So that's that. Alright, transfer energy. Energy transfer is a little bit different. We want to look how energy transfers from an object to another object. Alright, so this is no longer really the conversion that we're concerned with. We want to know how energy is being transferred between objects. Alright, so this guy here is named Nolan Ryan. He was a pitcher in baseball for a lot of years. He's in the Hall of Fame now. He's well before you guys, I'm sure. But he was famous when I was young. So this is Nolan Ryan, and he's a pitcher. So in this case, energy is being transferred from his arm, if you haven't guessed this already, from his arm and the motion of his arm as he throws forward into the baseball. So basically the energy is transferred from his body, the chemical energy in his muscles into the baseball, and it becomes kinetic energy when it leaves his hand. And then here we have our last example. Energy transfer. How is energy being transferred here? So this is a tennis player that you guys probably are not familiar with, but her name is Steffi Graf, and she was famous when I was young. So what's happening there? You've got a tennis racket. It's being swung by her. There's a tennis ball that's hitting the racket. So essentially the motion of the tennis racket transfers kinetic energy from it, the kinetic energy from the racket, into the ball. Now it's worth noting that all of these energy transfers and conversions, no energy is actually lost. That's called the conservation of energy principle. We'll talk more about that later. No energy is actually lost, but it might be converted into useless forms. So the amount of useful energy always decreases anytime you convert or transfer energy. So that's something you need to remember. And we'll talk about efficiency again later on. But the efficiency of a system is how much useful energy is preserved during conversions and transfers and so on. All right, cool. Thanks for watching.